Okay, so we're back for array time, and what we've done is we've made this new array, and now what we're going to do is try to rip out the old one. I think we're just going to kind of break everything first. So re-implement new array, and let's get to it. So this all goes away. The old one, all the intrinsics, bye-bye. We're going to rename ours to array. And then I think the next thing I'll do is I will search the compiler for array. We're not going to start in CodeGen. So here's our special case for array. What I could do before I rip all this out is just call that old array. No, so many things are going to be expecting array. This is going to be big. Let's just start there. Okay. Right. So in Prelude, we're now on new array for equals. So this is now just len. Oh, I actually have way better ways of iterating now, but not on my new array. We're gonna have to make iteration work on this new array, which means iteration probably needs to become user space too. We'll see. Length does not exist on type array, so we'll go to 210. Okay, and we crash. That's good. Okay, so we crash in CodeGen. It's not really what I wanted. So we found a struct value where we expected a pointer value. That's because our new array acts as a struct everywhere. I wonder which specific code we were on when this failed. This is an intrinsic. So what we may do is just remove, yes. So what's happening is these are still getting picked up when we call array new. So those are gone. Oh, feels so good. So now this is our special resolve intrinsic. So in the namespace array, these are our special functions we had. Guess what? There's now not a single built-in function for array. Okay. Oh, CodeGen. Right. So now we need to stop implementing these. This is where it really gets good. So here's array get. Not that bad, 4 lines, some all calls to helpers, but not that bad. Array get, array set, string get and string set. I still haven't even done. We'll do string soon. String is just array of char. That's not growable, so even easier. Look at capacity. Wow. So much just to get the capacity. Array length. It's pretty simple. We run the first expression, right? We generate the struct LLVM type. This is all stuff that we do in a generic way for our regular types for the rest of our language, but we're doing specially hard-coded here. So we get an array value, we actually load it, and then we get the capacity. We don't need to do any of that. Array new is probably even worse, yeah, because this is the one that has to alloc. And then I think, okay. So I think we alloc even if the length is 0. And then grow is a beast. So here we see we're multiplying our capacity times 2. If the capacity is 0, yeah, look, we're doing a select. So if capacity is 0, then the new capacity is 1, otherwise capacity times 2. So we wrote all this code kind of in a code gen kind of way. In the LLVMIR builder syntax, basically. We do our mem copy, so we're not using realloc here. And then we free the old. I'm not freeing the old because I'm calling realloc, so we don't have to. Yeah, array set length. Bye-bye. Array new returns a pointer to an allocus, so it needs to be inlined. So look, I think we're removing this nasty piece of tech debt as well. Look at this. Now what I could have done is just generate it as it's just inline because I have inline intrinsics. Right? Ooh. We're gonna dap this one. All right, ready? Here we go. Oh, there's spaces here. I need to get better at them. So dap isn't actually good for this. We could delete around. Delete around. Nope, that didn't work. All right, we'll dap it now. Bye-bye. Okay. Look. Oh, we're gonna get debug info for free. Oh, it's so good. Array length goes away. Array capacity, array data. Oh. This is CodeGen Expert. Okay. So we can keep array literal. So the question is, do we desugar this to a loop? Or do we keep it and make CodeGen know about it? And CodeGen would have to call array new, which is no longer built in. So no, it's terrible. So we're going to desugar this into a loop. So this will actually get deleted in the typed AST. This is going away. We're going to keep it in the parsed AST. We're going to parse those array literals. We're just not going to make them part of our typed IR. So for now, well, I'm going to remove it. You can see what we did though. We probably should have desugared this even then. But we have the element, so we iterate, and then we did. So we actually unrolled the loop, which is kind of nice, right? It was never actually a loop at runtime. Anyway, just think of all the room for bugs. All this code I've been deleting. all of this. It's so duplicative of the same thing, of this length capacity data thing. No, it's so nice. And I have had so many bugs. That's why I'm taking the time to do this. String from char array. So this can totally be userland as well. So this is from, I think we call it from bytes. No. From chars. Yeah. Oh, that's clever. Yes. So we can just implement. We don't have a string new with a length. That's the problem. So this kind of becomes. I was mim copying it. That was actually pretty good. It's probably what we'll do. Implement in userland with mim copy. Okay, dump. So this means we won't even be able to print it, but that's fine. If you want to print it, just print the AST. I ran into this with the for loops as well when I got rid of them. Back when I got rid of them. Don't need array. This is inside evaluate expression inner. Oh, it's just the very first one I implemented. Or it's just the first here. So for parsed expression array, match expected type. Okay, this is all staying. And now we just generate a block that sets every element instead of an array literal typed expert. So we have quite a few to-dos here. We're not going to get this done tonight, but it looks like we can compile. We can. So let's run it. We'll run new array. It's not going to work. But where do we actually fail? Okay, we fell right there. Now, that's probably from Prelude, though. If we're doing array literals anywhere. Unfortunate that it's the same symbol. I realize that. Yes, here. So we can't do this. So we can do that, though. Okay, for this one, I'm going to do a stack reference, and I'll dereference it here. Boom. Implement in userland with memcopy. It's 2502. String. Oh, right. Now that we're successfully calling it. So what I actually could do is keep this. I could presume the layout. Basically, CodeGen could rely on the fact that the array is laid out the way it is, and we could grab its data and still implement this as an intrinsic for now. But we just deleted all the code that kind of does that, and obviously we don't want it. It would just be kind of a shortcut, because if we can't do that, then we need to write from chars in here, which means we need string new, which we don't have. We only have the literal, so we really just need string new. These don't need to be intrinsic now that we have pointer. So we can make string a struct just like we just did with array pretty easily. The answer for now might be to remove any calls to, okay, it's called twice. If I remove char to string, then a lot of functions won't work. If I do string new now, I'm gonna have to do it as an intrinsic. It's also getting late. So what I'll do here, I'm gonna crash from chars to do. Okay. Mm-hmm. Can I redo? Undo. It's been long enough that that's an undo, not a redo. Okay. Wait, why'd you get here? Oh, because it's still being code-gen even though I'm not calling it. Okay. So I got that wrong. We're going to crash in from chars. We're going to make it not intrinsic. String from char array is not going to be an intrinsic, which means we don't need to mention it here. And it means I know you're all unused, just show me the error, and it means we don't need to mention it here. And we should compile now. Yeah. And we get all the way to where we call So new array. This is now just our built-in array. The language doesn't know about it yet, so there's things that still don't work, so we can't iterate over it. For C and X do. So for example, that's not going to compile. Array C is not iterable. This used to work. But that is pretty easy to fix. We just override item type of iterable and then fix all the generated code, which we're calling by name. So we synthesize code that calls like array.length and array new. So actually it's going to work pretty well. That's neat. Yeah, we just don't need to. Of course, we're depending on char to string. So let's go back to, let's just use U8s. Well, let's just use int. That's like our default. So we'll do 1, 2, 3, and then this needs to be 1, this needs to be 3, z, and it's going to be 99. And now we're going to, okay. So for ln, glgl, gl, int, bang. The problem is new lines. Where are we calling string from chars? Someone help me out. Is it in something we're printing? String. Like, if only this actually worked and didn't just print the line where we crash. Whoops. That's not what I wanted. Yeah, I tried to make it work. It just we need to do caller location. Ah, it's in println. Yeah, and I don't have a way to concat one char to a string because I just haven't built out string. No. Concat also calls it. Who's calling print line though? Maybe an assert failure? No, I just want to get to where there are no crashes. And then finish the rest. But yeah, who's calling print line? Realec. You dirty dog. Hey. All right, we did it. Doesn't look right. Aren't we supposed to print 1, 2, 3? Now we got an assert failed. Well, it probably means it's time to go to bed. We'll keep marching on. The assert fails earlier than that. We're malicking 8. Yeah, something's gone wrong in the compiler where what we were doing before is no longer what we are doing. So I just need to more thoroughly remove everything that references sort of the built-in here. Maybe even just go ahead and remove this type so it doesn't interfere, and then go into debugging mode, or maybe the problem will be gone. Hate to end it there, but I think that has to be it. Thanks for watching. Just to conclude, we are midway through the journey of making our userland array our built-in array and removing the built-in array. We've removed a ton of code, which normally you'd be proud of, but the problem, here's all the code we've removed, is that nothing is working. So we can't really be too proud, but I promise you it will all work and it will be way less code. All right, till next time.